All right, Section 9, rail welding. Continuous welded rails provide many benefits to the railway industry, including elimination joints, increased rail life, reduced track deterioration, and reduced maintenance costs. Many of the railway lines in the United States now have welded rail to make some of the extent of the continuous welded rail is being installed on the annual basis. Rail welding can be done stationary, specialized welding plant, or on the track on site, or portable welding techniques. In the United States, the majority of the rail welding consists of aluminothermic or thermite welding, flash butt welds, and gas pressure welding. The flash butt weld would be produced in a narrower heat effect zone with the thermite weld, and has also made a consistent hardness through the furnace weld, which is normally resulting in less welding failures. Electronic flash butt welds. Flash butt welding of the rails has been most method of pot welding of the rails in the world of some time. The process has been proven to make strong, reliable welds. The flash butt weld process typically performed by a stationary welding plant. However, the recently developed mobile flash butt welding process has resulted in portable and track alternative. The flash butt rail welding is a method of forging two separate rails together with a generating electrical heat unit and sufficient flashing of the parent metal to take place. One temperature risk and the fusion of the rail ends and the pressure together with the application of the force of the ultimate leads to the welding of the rail ends. Basically, complete components of electrical flash butt welding. There are three basic components that are required to complete with the flash butt welding process. One, a clamping mechanism sufficiently tightly hold the rails being welded in position. Two, a forging mechanism that dual functions of bringing the rails into the contact of minimum force during the heating stage. B, apply high forces to the rails upon completion of the welding cycle. Extract impurities and finalize fusion of the weld. Three, a transforming that will reduce the main supply voltage, suitable welding voltage, and make available sufficient current to heat the rails being welded. The welding current required with the varying depending on the rail size across sectional area being welded. It is critical that the rail ends of the similar dimensions with specified tolerances that they are thoroughly cleaned and prior to the welding. A rail end that has not been properly cleaned may result in one oxide inclusion, or the dimensions should be within similar tolerances to avoid lack of fusion. Flash butt welds of the considered superior to thermite welding in the forging process. The strength of the weld is almost the strength of the parent metal, where the thermite welding is casting may be suspectably imperfections like porosity, inclusions, and lack of fusion. Figure 53 shows a newly completed electrical flash butt weld. Figure 54 shows an electric flash butt weld in the track, and 55 shows a new track electric flash butt weld. To ensure the proper electric flash butt weld is properly free of extra and can carry most of the taken, the following corrected welding procedures. Proper alignment is necessary to begin with the welding process. The welding must then be sheared and grounded properly. Transverse development in the electrical flash butt weld, normally originating with oxidation containing an inclusion of the weld, may also fail to result lack of fusion of stress or riser. The gas pressure welding is a rail alternative process similar to the flash butt welding process, but it also consists of the fusing of the rail ends together with no external metal fill required to fill in between the rail ends. This rail welding process has been extensively used in many countries because of the reliability and simplicity of the welding process. Gas pressure welds are a solid phase welding technique. The mixture of oxygen and silicone of the heating of the rail ends that reach the temperature of approximately 2400 degrees Fahrenheit. For applying high pressure to both ends of the rail ends, the process is normally done by a welding plant by using multiple in-track capabilities. The process requires the ends of the rail to be butted against each other and applying the pressure. Once the rail ends are putted together, they are heated evenly distributed acetylene or silicone burners until they are fused solidly. Upon completing of the railway trimmer, the device is removed from the excessive welding material from the rail and weld section until the uniform dimension is achieved. With a proper post-weld heat treatment, the hardness of the weld is comparable to parent rail steel. To ensure good pressure welding adherence to the welding procedures, proper rail end alignment, proper shearing, grinding, also nearing necessary to make up gas pressure weld. Gas pressure welds can originate with inclusion of lack of fusion or stress risers. Aluminothermic welding. Aluminothermic welding process fusion result of exothermic reaction between iron oxide and aluminum, which produces high heat generation. Since the reaction of exothermic is comparable with the producing of the heat that is sufficient to result in the molten state in a metal, can be cast to bond rail ends together. The reaction can be altered, controlled dependent on the chemical reaction of the iron oxide aluminum portions. The exothermic reaction between the iron oxide and aluminum is done by the colonical metal container lined with the magnesium that is referred to as a crucible. After the exothermic reaction occurs with a few seconds, approximately equal portions of molten steel liquid equipment, aluminum oxide or separated aluminum oxide is lighter, will float to the top of the molten steel. All of the aluminum oxide has been floated to the top of the crucible. The molten steel is released from the bottom of the crucible. The rail ends are preheated with the proper temperature before the release of molten steel. The molten steel pours down to the hardened sand mold, then packed in Luton sand and a special paste around the two rail ends being joined. During the process, the rail ends are partially melted at extremely heat with the molded fills. When the pour is complete, with the weld is allowed to coal and solidify. Once the molten steel solidifies, the mold removed, the weld is cleaned and finished with the produce of the joint. The two predominant aluminothermic welding process may be used in railroads as referred to as thermite process and Buet processes. The steps of aluminothermic welding process consist of preparing rail ends for welding, rail end separation, setting the welding gap alignment, rail clamp application, applying the mold assembly, placing the weld material into the crucible, preheating the rail ends, igniting the welding material, removing the mold assembly, shear, axis head welding material, rough grinding, and the excessive material, final grounding of welding material. This shows a thermite weld in the track. This also shows a Buet weld in the track number 58. Aluminothermic welding defects originate with the railhead web base. The defective condition may result in incomplete preparation of the welding material, lack of fusion rail end and sag, entrapment, shrinkage, fatigue, discontinuation. Many of the defects of aluminothermic welding will normally originate with improper rail alignment, improper preheat conditions, and inadequate with welding change in the material's introduction, moisture, and improperties during the welding charging process. Section 10, rail grinding.